There we go. All right, so the difference here is it doesn't have a 0 on one side of the inequality. I kind of want to move everything, all of my variables, everything over to one side. Even the 3, I want to move it all over to one side. So I've got my 2x squared. I'll probably subtract the 5x over. I'll subtract the 3 over. The inequality has not changed. It's still greater than or equal to. All that is greater than or equal to 0 now. All right, so now this is similar to example 1. I need to factor it. I need to graph it and see where I am. In this case, greater than or equal to 0. All right, so let's talk about factoring real quick. Can I just do the whole multiplying to be -3, adding up to -5? Can I do that this time? No, how do you guys factor this? I think that 2 is kind of causing a problem there.
-3 times 2.
Oh, so the factor by grouping, I guess is what we're talking about. Yeah, the -3 times the 2 is a -6. I kind of have some side work over here. I want factors of -6, specifically that add up to -5. So like 1 times -6, -6 times 1. Let's see, -2, -3. Oh, sorry, -2, +3. +2, -3. Do any of these add up to -5? -6 and 1, the first ones? Those add up to 5. So I'm going to break that -5 into a 1x and a -6x. All right, so then I'm going to factor out a GCF, which I think my greatest common factor there is just an x. And my GCF on this group is a -3. So I'm at a 2x plus 1 again. So now their GCF, what they have in common now is the 2x plus 1. So when I factor out what they have in common, I'm factoring out the 2x plus 1, and I have an x minus 3 left over. Okay, so I got the factored form, which helps me get my x-intercepts on my graph. They wanted me to do this graph by graphing, right? So I'm going to set my factors equal to 0 here. If I get the 2x plus 1 equal to 0, let's see, I'll subtract the 1 over and divide by 2. So -1/2. If the x minus 3 equals 0, I'll add the 3 over, so I got a +3. These are my x-intercepts. At a -1/2 and a +3. All right. Was this parabola? I know it's a parabola because it's an x squared, degree 2. Is it facing up or down, I guess? I don't need to go find where the vertex is. I really just want to know, is it facing up or down? I got one up, I got one down. Up. How do you know? How do you know it's up? Oh, it's not negative. This is a positive leading coefficient, the 2. It's a +2. Okay, so facing up like this. All right. And I needed this parabola to be greater than or equal to 0. All right, so that whole parabola is greater than or equal to 0, like above 0 up here. All right, so I actually have 2 sections. I'm going to break this into 2 pieces. I'm going to break it into 2 inequalities for those 2 different parts of my graph that are greater than 0. So that left side there is going to be from -infinity up to the x value -1/2. Now, parentheses or bracket? Kind of have to ask myself this question whenever I do an interval. Parentheses, not included, bracket, it is included, yeah.
It says equal to 0.
Oh, that little equal to. Okay, so bracket you said? Okay, because of the equal to bar, brackets. All right. Union, like I'm going to combine that with this other interval, which picks it up at the 3. And again, because I can equal 0 and it hits 0 at the 3, I can equal that +3 up to infinity. All right, so here are my 2 separate intervals. Okay. So we're going to take a look at solving the same thing just in a different way. We're going to solve by using a sign line this time. We just did by graphing. Let's look at a sign line. I'm still going to subtract it over. So I have a 0 on one side. The 0 makes it so much easier just because I can tell if I'm above or below 0 just by looking at a positive or negative. I don't even care what the numbers are exactly. I just care positive or negative. So this just makes it so much easier. I'm going to factor this the same way we did before. I got the factors 2x plus 1 and x minus 3 before. I'm going to put these numbers, the negative 1/2 and the positive 3, I'm going to put that on a number line this time. All right, and I'm going to test each of the 1, 2, 3 sections of this number line. All right, so let's test like this lowest section here. All right, so let's see, Francisco, pick something less than negative 1/2. I don't really care what it is, just pick something less than negative 1/2. Negative 2, sure. So I'm going to put the negative 2 into my inequality here. 2 times negative 2 squared minus 5 times negative 2 minus 3. Is that, or is it not, greater than or equal to 0? All right, so you can do it in your mind, you can put it in the calculator, whatever. I don't even care what this number is. I just care if it's greater than or equal to 0. Would it be easier if I did the factored form? You think it's greater than? What if I did the same thing, but the factored form? I'm still going to plug in the negative 2, like you said. But I'll do a 2 times negative 2 plus 1, and then a negative 2 minus 3. So if the factored form, I really just care if these are positives or negatives. Like this is negative 4 plus 1, that's a negative. And this is like a negative 5. Negative times negative, is that greater than or equal to 0? Is a negative times negative greater than or equal to 0? Yeah, it's a positive. So this part works. Check mark. All right, that worked. All right, so now I'm gonna try not a negative 2, but I'm gonna try something else in this middle section here. All right, so Alina, pick a number between negative 1/2 and 3. 0. All right. So if I plug a 0 in, 2 times 0 plus 1, and then a 0 minus 3. 2 times 0 plus 1, that's a positive 1. 0 minus 3 is a negative number. Again, I don't even care what those numbers are. I just care if they're positive or negative. Positive times negative is negative. Are negative numbers greater than or equal to 0? No, negative numbers they're not even equal to 0. They're strictly below 0. So for that reason, this part is out. All right, and last section here, we need to pick some number. You can pick, I don't know, 500, whatever. Pick a number greater than 3. Right, so Abdi, which number do you want to pick that's greater than 3? 6? Okay. So a 2 times 6 plus 1, and then a 6 minus 3. So 2 times 6, 12 plus 1 is positive. 6 minus 3 is still a positive. Positive times positive is a positive, which is greater than or equal to 0. So then I'm going to go with, yep, that part works. All right, so now I'm going to do my interval for these 2 sections that worked. I'm going to go from negative infinity up to the negative 1/2. And again, I had the little equal to bar. So I'll have a bracket on the negative 1/2. Union, like combined with, I put a bracket on the 3 again, because I can, if I plug in a 3, it makes me 0. And I said I could be equal to 0. So we're going to be good from there up to infinity. All right, so I actually got the same answer. Just use the number line as opposed to the graph. Same thing. Okay, any questions on example 2? You guys at home? You guys have any questions? We're good. Audrey's good. No questions? Yeah, pretty much. All right, so then let's look at this example 3 then. All right, the nice thing is they factored it already, except for there's a small problem. Every time I factored it, I had my factors with a 0 on the other side of the inequality, just because it's way easier to tell if I'm above or below 0. I'm just looking for positives or negatives. This one doesn't have a 0 on the other side though. This has got this 20 right here. All right, so I'm actually going to subtract the 20 over. And I think I'm going to distribute this as well. X squared plus x, and then I'll subtract the 20 over. All right, so I do like the factored form, but this wasn't entirely factored. It didn't have a 0 on the other side. So now if I factor it, can you guys think of what multiplies to be -20 and adds up to a +1? Multiplies to be -20. A 4 and a 5. Oh, wait. So a +5 and a -4? +5, -4, and then x times x is the x squared at the beginning there. All right, so factored. I just want to point this out because a lot of people stop right here. They're like, oh, great, I needed it factored, but that's not exactly what I need. I need my factors on the other side of a 0. So if you need to make yourself a note about that, go for it. I will then set each of my factors equal to 0, which this first factor, I think a -5 makes that 0. -5 plus 5 is 0. The next factor, a +4 makes that 0. 4 minus 4 is 0. All right, so if I'm doing this by graphing, I've got some x-intercepts at a -5 and a +4. All right, so I'm not actually going to look at the original way they put it. I'm going to look at, after I got everything on one side, it looks like a parabola. It's a degree 2 polynomial, it's a parabola. And it was a positive x squared, so like my parabola is facing up. So it has to hit those two, but it has to go something like this. I didn't even find the vertex. I just cared facing up or down and the x-intercepts. All right, so this is supposed to be less than 0. So like negative numbers, right? That would be these guys down here. These are less than 0. So that would be from the x value -5 up to the x value 4. Do I put parentheses or brackets on the -5 and 4? What does no mean?
Well, you don't put brackets there because they will be.
No brackets but parentheses? Yeah, because what I circled, this is strictly less than, not equal to at all, so parentheses. All right, so there is my interval. Sometimes people look at that and they're like, oh, that's an xy point, right? No, that is an interval from some x value to another x value. So from -5 to 4. All right, so you guys should get the same answer on this one. I'm gonna give you guys a sec, take a sec, and do this by the sign line. It's the same inequality, you're just gonna do the sign line. You probably should get the same answer, just in a different way. So Sky, just whenever you're ready, let me know how you did the first part of it. You don't have to tell me the final answers. Let me know how you started it. So yeah, Sky, just let me know how you're starting it. And then Brett, I'm gonna have you test different sections once we get there. Just be aware. Sky, are you there? No response. All right, well, I'm gonna have to start it out then. I'm actually gonna start it like we did up here where I got that 20 on the other side. And I actually factored it, like I distribute my x I subtracted the 20 over to have 0. I like the 0 there. Factor it just like we did before, which we had x plus 5 times an x minus 4, which is less than 0. And this gives me the same x values of -5 and 4. It just is going on the number line this time. All right, so then I'm going to reach out to Brett. Brett, help me test these sections. So what number are you going to test first?
-5.
A -5. So if I plug a -5 in, it's actually going to. Oh, okay. So something over to the left of the -5. There you go. So -6. So -6 plus 5 and -6 minus 4. Is that or is it not less than 0? Let's see. I get a negative times a negative. So is a negative times negative less than 0? I don't even care what the number is. Is it just less than 0?
No.
No, that's a positive number. It's bigger than 0. So this part is out. All right. So Brett, pick another number then. Pick a number for the middle section.
0.
0. So 0 plus 5 and 0 minus 4. So I get a positive times a negative. Is that less than 0?
Yeah.
All right, that part's good. And then pick some number greater than 4.
That one we can do a 5 on.
That'd be a what?
5.
A 5. Okay, so 5 plus 5 and a 5 minus 4. I get a positive times another positive. Is that less than 0?
No.
Nope. Positives are greater than 0, so that part's out. All right, that means that I know it's the middle section, but I need to know if I should put like a square brackets or a parentheses. And that's based off of the sign we had here. No, Zach, I was calling on Sky. So I'm gonna go from -5 up to 4. And again, because it's just strictly less than, it's not equal to, I'm gonna put parentheses on these. All right, so I got the same answer, -5 to 4, parentheses. I just did it off of a number line instead. All right, and then last problem here, what is the domain of this function? All right, domain for square roots. If it's a domain, if it's something I can actually graph, I should have real numbers, no imaginaries, right? No square root of a negative or anything. So I want, why is this in my inequality part of my notes? I don't see an inequality there. But didn't I say I want to take the square root of a positive number? How can I write that as an inequality? Let's see. Positive numbers. All positive numbers are greater than 0, right? So whatever I'm taking the square root of all that, I want it to be greater than 0. Now, do I want it to be equal to 0? Can I take the square root of just straight up 0? I can take the square root of 0, so I can have a little equal to bar. Square root of 0 is 0. It exists, that's fine. All right, so that's why it's in this inequality section. I need to factor this, which I'm going to start with the GCF, a greatest common factor of x. So x times x minus 3 has to be greater than or equal to 0. All right. I'm going to set each of these factors equal to 0. So I get x equals 0, and then the other factor, I get a positive 3. 3 minus 3 is 0. So I got to figure out, am I going to put those on a graph or on a number line? I really don't care. You just have to pick which method you want. So Ryan, which method do you prefer? The graph itself? Okay. So on my graph, I have a x-intercept at 0, 0 and at 3, 0. This is a positive x squared, so it's facing up, parabola's facing up. Okay. And I want this to be greater than or equal to 0, greater than, like above the 0. So I have two sections here, which means this first section is from -infinity. I always have parentheses on -infinity, never brackets. You're never going to get out to the -infinity and put a little dot there, are you? Can't get there. So you have the parentheses there. And then up to let's see, this was 0. And do I have parentheses or a bracket at the 0? Let's see. The little equal to bar here, this is my deciding factor. Brackets, yes, the equal to bar means I've got to have a bracket. Nice. Good job, Audrey. Union, like combined with this second interval, which I will have a bracket on the 3 as well, up to infinity. I always have parentheses on infinity. Okay, so here is the domain of that function they gave us.